and for today's lesson, we are going to learn about the Pythagorean identity. So to get started for today, I want to bring your attention to this section of a circle. And we're going to say that it's part of the unit circle because as you can see, we have a radius of 1. And if you think about a triangle and what we know about the Pythagorean theorem, we know that we can drop a perpendicular in this triangle, and we now have one of our bow tie triangles. So here is our perpendicular. And we know that in the Pythagorean theorem, which I'll write over on the side, we know that the Pythagorean theorem is a squared plus b squared is equal to c squared. So if you think about it, that is one side of a right triangle squared plus the other side of a right triangle squared equals the hypotenuse squared. So if I made this side A and this side B and this side is the hypotenuse C, we can see that it would certainly satisfy the Pythagorean theorem. But what we know also, and what we've been learning, is that the x side of an ordered pair, so if we think about this being like going over some sort of x value and up some sort of y value, we would land at this point. But this point, more specifically, using the unit circle, we can say that the x value is actually the cosine of theta. So the cosine of theta is our x value. And then we would go up a sine of theta. So the sine of theta is our y value. And that's another way that we've learned how to express this, where our radius is equal to 1. So instead of using A's, B's, and C's, what we can use instead is we can substitute A for cosine of theta, that whole quantity squared. Plus, instead of B or Y, we can use the sine of theta squared. And this would be equal to our hypotenuse, which is our radius, and that length is 1 squared. Now, the way that we express that is instead of just like cosine of theta squared, the operation itself of cosine is going to be squared. So we would say cosine squared of theta plus the operation of sine gets to be squared. So sine squared of theta is equal to 1. And that is our Pythagorean identity. Sometimes we write it as sine squared of theta plus cosine squared of theta is equal to 1. Now, please note that theta is not getting any bigger. The theta remains the same. It's just the operation is what is going to be affected. So let's talk some bad math. What is considered bad is that sine of theta quantity squared means sine of theta times sine of theta, where the operation itself is what is going to be squared. Not sine of theta squared. That is bad. The angle itself is not what is going to be squared. So please be very, very careful. Sine of theta squared is equivalent to sine of theta, that quantity of the angle is being squared, not the whole operation itself. So this right here is bad. This up here is good. So whenever you see a parenthesis squared, the operation itself is going to be squared. So please just be very, very careful. We want to make sure that we know what is equal and what is not equal. So I want you to know that the sine of theta, that whole quantity squared, is not equal to the sine of theta squared. Instead, it is equal to sine squared of theta. That would be good. Okay, so we've talked about this before, and what's really cool is that this is called an identity. And identities are true for any real value of theta. So that is very, very important to note. So what kind of problems can I solve with the Pythagorean identity? Well, like any identity, the Pythagorean identity can be used for rewriting trigonometric expressions in equivalent and a lot of times more useful forms. Now, the Pythagorean identity allows us to convert between sine and cosine values of an angle without actually finding the angle itself. So you're not required to know what the angle is, but we can go back and forth. So for example, if you consider the example of the angle theta, which is in quadrant number 4, for which the sine of that angle is equal to negative 24/25. We can use the Pythagorean identity along with the sine of theta to solve for the cosine of theta. And what that looks like is this. So I'm going to use that the cosine squared of theta plus the sine squared of theta is equal to 1. And I know that the sine of theta is negative 24/25. So I am going to replace the sine squared of theta with this by writing the cosine squared of theta plus the quantity negative 24/25, that whole quantity will be squared, equals 1. So now negative 24/25, you're going to need a calculator. That equals, just for time purposes, we have cosine squared of theta plus negative times a negative is a positive, so that's 576/625 is equal to 1. I am going to subtract 576/625 on both sides. And when I do that, I have the cosine squared of theta is equal to, and I am going to rewrite 1 so that it is conveniently written as 625/625 minus 576/625. What that allows me to do is to have a common denominator. Now, 625 minus 576, that is actually equal to 49. 49/625. Now, just like we would for any other quadratic, we're going to take the square root of both sides. And when you take the even root of both sides, you now are going to have plus or minus in your answer. That is going to be 7/25. Now, because the sine of cosine is determined by the quadrant that the angle was given to us in. And angle theta was given to us in quadrant number 4. So since it is in quadrant number 4, our cosine value must be positive. So our answer is going to be a positive 7/25. And that is our answer. So our answers are either going to be positive or they are going to be negative. Let's go ahead and move on to the next page to do another example. In example number 2, we have theta, angle theta is in quadrant number 3, and the cosine of theta is equal to negative 3/5. And the question is, what is the sine of theta? So we're going to be using that cosine squared of theta plus sine squared of theta is equal to 1. So I am going to replace cosine with negative 3/5. So that's negative 3/5 quantity squared plus sine squared of theta is equal to 1. Negative 3 times negative 3 is 9. 5 times 5 is 25 plus sine squared of theta equals 1. And I'm going to subtract 9/25 on both sides. And when I do that, I am left with sine squared of theta is equal to, and I'm going to rewrite the number 1 in a convenient way of 25/25 minus 9/25. I need that common denominator. And when I do that, I end up with the sine squared of theta is equal to 16/25. And now I'm going to take the square root of both sides, and when I do that, I find that the sine of theta is equal to plus or minus 4/5. Now, because this lies in quadrant number 3, that means that the sine of theta would be negative because only tangent is positive in quadrant number 3. So therefore, my answer for sine of theta is going to be negative 4/5. And here is our answer. So what I would like you to please do is I would like you to please pause the video and I would like you to complete the solo, the pair, and the team. And when you have an answer, I want you to restart the video and I want you to check your answers to make sure that you did it correctly. Make sure your answer is in simplified radical form, so if you end up with a root in your bottom, you might have to rationalize. All right, let's go ahead and check our answers. So your answer for the first solo question should be the cosine of theta is the square root of 3 over 2. And that's because in quadrant number 4, cosine is positive. For the second pair question, you should have ended up with net cosine of theta equals negative 40 over 41. And that's because cosine is negative in quadrant number 2. And for our final team question, you should find that sine of theta is equal to a positive square root of 731 over 30. And that's because in quadrant number 1, sine is positive. That is the end of today's lesson. If you have any questions over anything we just talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.